We often take pride in our intelligence, marveling at our technological achievements and scientific discoveries. But when it comes to understanding the universe, the vast, mysterious expanse in which we exist, we've only just begun to uncover its secrets. For all our advances, we've merely scratched the surface of what's out there. The universe, as we currently understand it, is about 13.8 billion years old. Not only ancient but also still expanding. Yet the most fundamental questions remain unanswered. Existed before the universe came into being? Why did the Big Bang happen at? These are some of the most profound and puzzling mysteries science has ever confronted. The Big Bang itself is the prevailing theory explaining the origin of the universe. It suggests that all of space, time, matter, and energy originated from an extremely hot, dense point. In a fraction of a second, this point expanded rapidly and dramatically. Over billions of years, that expansion slowed and eventually gave rise to galaxies, stars, planets, and everything else we see today. It's a theory, supported by a vast amount of indirect evidence. But despite its acceptance, there's still so much we don't understand. One of the biggest challenges in studying the Big Bang is that we can't directly observe it. We can't see the moment the universe came into existence. All we have are clues, mathematical models, theoretical predictions, and one very important piece of observational data. The clue is known as the cosmic microwave background. It's a faint glow of radiation that fills the universe, and it's believed to be the remnant heat from the Big Bang itself, first predicted in 1948 and accidentally discovered in 1965. This ancient light is the oldest electromagnetic radiation we can detect. It offers a kind of snapshot of the early universe taken roughly 380,000 years after the Big Bang. But even with this remarkable discovery, our understanding of the universe's true beginnings remains frustratingly incomplete. The cosmic microwave background doesn't show us the moment of creation. It shows us what came just after. To see further back in time, we need a new kind of tool. The tool is the James Webb Space Telescope. Unlike its predecessor, the Hubble Space Telescope, which observes visible and ultraviolet light, James Webb is designed to detect infrared light. The difference is critical. As the universe expands, the light from its earliest objects stretches out, shifting into the infrared part of the spectrum. This means that by observing in infrared, James Webb can look much farther back in time, essentially allowing scientists to see closer to the very beginning of the universe. You could think of the James Webb Telescope as a kind of time machine that's capable of detecting the faintest and oldest light originating from the first galaxies that ever formed, and it's already delivering results. On July 12, 2022, the telescope released its first full-color images offering breathtaking views of the Carina Nebula, Stephan's Quintet, and distant galaxy clusters in what's known as the Deep Field. These images were not only beautiful but groundbreaking, providing new levels of detail and insight into parts of the universe we've never seen so clearly before. But those initial images were just the beginning. Soon after its debut, the telescope spotted what is currently considered the oldest known galaxy, a system that formed only about 300 million years after the Big Bang. In cosmic terms, that's practically the blink of an eye. From the moment the universe began, discovering such an ancient galaxy offers us a rare glimpse into the earliest stages of galactic formation and helps answer questions about how the very first structures in the universe came together. James Webb's location is also a key part of its success. Hubble, which orbits Earth at around 570 km above the surface, the James Webb Telescope resides at a special point in space called Range Point 2. It's about 1.5 million kilometers away from Earth. This distant position allows it to remain in a stable orbit free from interference caused by Earth's heat and light. The telescope also boasts a 6.5 m primary mirror made of gold-coated segments that can gather over 6 times more light than Hubble. A massive 22 m sunshield protects its sensitive instruments from solar radiation, keeping everything cool enough to detect even the faintest sources of infrared light. This impressive design allows James Webb to do more than just look at galaxies billions of light years away, revolutionizing our understanding of all kinds of cosmic phenomena. For instance, it's helping scientists study exoplanets, planets orbiting stars outside our solar system. One early target was WASP 96b, a hot gas giant, where James Webb detected signs of water, vapor, clouds, and even hints of various chemical compounds. These findings suggest that one day we might be able to analyze the atmospheres of rocky, Earth-like planets in similar ways, potentially identifying worlds that could support life. But one of the most surprising discoveries made so far involved galaxies in the early universe that seemed to defy all expectations. Within just 500 to 700 million years of the Big Bang, James Webb observed 6 massive galaxies. What stunned astronomers was their size and level of development. Some of these galaxies may be as large as our own Milky Way. According to existing theories, the universe was supposed to be too chaotic at that time for such large structures to exist. This discovery throws a wrench into our current models of galaxy formation. It suggests that galaxies might have formed much faster and more efficiently than we previously believed. If this finding holds up under further scrutiny, it could force scientists to completely rethink how the early universe evolved. It may even call for revisions to the timeline of cosmic history as we understand it. And that's part of what makes the James Webb Telescope so important. It isn't just filling in gaps in our knowledge, challenging long-held assumptions and forcing us to ask new questions. And we're just at the beginning of its journey. The James Webb Telescope is expected to operate for many years, possibly even decades. What more will it reveal as it continues its mission? Could it finally give us a direct look at the first stars ever formed? Could it provide the data we need to understand how black holes emerged in the early universe? Might it even offer hints about what came before the Big Bang? A question that continues to baffle scientists and philosophers alike. Only time will tell what astonishing revelations the James Webb Space Telescope will deliver next. With every observation, every newly captured image, and every analyzed data point, we are inching closer to answering some of the most profound questions humanity has ever dared to ask. What were the very first stars like? How did the earliest galaxies form and evolve? What role did dark matter and black holes play in shaping the structure of the cosmos? And perhaps most intriguingly, could there be signs of life on distant planets? Life that challenges everything we thought we knew about biology and our place in the universe. The telescope's journey is just beginning, and its potential is virtually limitless. The coming years, scientists expect to use it to study not just the vast scale of galaxies billions of light years away, but also the fine details of planetary atmospheres orbiting distant stars. Each new discovery adds a piece to the puzzle, painting a clearer picture of the universe's history, from the fiery moments just after the Big Bang to the complex structured cosmos we inhabit today. What makes this era so exciting is that for the first time in human history, we are not just speculating about the origins of the universe. We're observing them. We're witnessing light that has traveled for over 13 billion years to reach us. That light captured by James Webb's powerful instruments is allowing us to look back through time and space in a way that was once thought impossible. With each new image, understanding is deepening and new questions are emerging, questions we didn't even know to ask before. As the James Webb Telescope continues its mission, one thing is certain: the universe still holds countless secrets waiting to be uncovered. Some may fundamentally alter our understanding of reality itself. Others may simply remind us of how much wonder and complexity exists beyond our tiny blue planet. Either way, this journey is one worth following. If you're fascinated by the mysteries of space, the origins of the cosmos, and the groundbreaking science that's reshaping what we know about existence itself, be sure to subscribe. Stay with us as we explore each new breakthrough, one discovery at a time, and together continue the journey into the unknown depths of the universe.